So another example. We have a handful of charges here, and they're all spaced out. And they're all charge Q. Okay. And I have a cylinder, and the cylinder is like that. Okay, so each of these charges is a distance L away from each other. Okay, and so we can say that Q is 61.3 picocoulombs, and we can say that L is 1.25 centimeters, and I have a cylinder that encompasses 3 of those little charges. So I want to know what's the total flux through the cylinder. And you look at it and say, well, gosh, that's going to be really complicated. Well, no, it's not really complicated, because Gauss's law tells us that this is pretty straightforward. Gauss's law tells us that the total flux is going to be enclosed charge over epsilon naught. And so what we have here is the enclosed charge is 3Q over epsilon naught. So that means this is going to be 3 times 60, well, the total there is 61.3, or 3 times 61.3 times 10 to the minus 12 coulombs, divided by 8.85 times 10 to the minus 12 coulombs. And so what that gives us is, that the total flux is going to be equal to 20.8 Newton meter squared per coulomb. Again, we do not have to do the really nasty integral. This is the power of Gauss's law.